Welcome to Pyography Made Easy. I'm Brenda. In this episode, I am going to be doing a product review of Ortur's Laser Master 3 20-watt edition laser. Prior to receiving this laser, I had never used a laser before. So needless to say, this product review is going to be from a complete beginner's perspective. Also, my mindset while doing this product review was from the aspect of how could a laser be useful for pyography, especially if somebody was wanting to start a pyography business or expand their current business. Before I start the review, I need to mention that I did not pay for the laser. Ortur sent me the laser for free, along with a lot of accessories. That said, this video is still my opinion, and I do not receive any compensation whatsoever from Ortur if you should buy any of their products. If you should purchase something using one of the Amazon affiliate links I put in the video description, then Amazon shares with me a small percentage of their selling fees, but that money comes from Amazon, not Ortur. Regardless of all of that, please do not take this as a plea to buy anything. If you buy a laser or any of the accessories, it should be because you want or need it. Well, with that out of the way, let's begin the review. This large rectangular box contains both the laser and the air assist pump. Each box has all of the needed components securely protected with packing foam. As you can see, the laser requires assembly, but it's not overly complicated. I'm not going to waste time explaining how to put the laser together. There is an instruction manual that details the process. Also, Ortur has a video that shows how to put the laser together. I will put a link to that video in the description below. Either one of those two methods will explain the assembly process better than I possibly can. It took me around 45 minutes to put the laser together. The outer dimensions for the laser frame are 23½ inches wide by 26 inches deep, and it is 2¼ inches tall. The X-axis support bar is 22¼ inches long and 3�5 inches tall. The laser frame inside dimensions are 20⅛ inches wide by 20�¾ inches deep. The laser module is 4¾ inches tall and 2�3/8 inches square. The laser frame and module weigh 10 pounds. The laser module alone weighs 1.1 pounds. The AC adapter can handle an input range of 100 to 240 volts. There is a cord that goes from the adapter to the laser and a power cord. The adapter measures 6�5/8 inches long, 2�5/8 inches wide, by 1�5/8 inches tall. The laser connection cord is 45�7/8 inches long. The power cord is 48½ inches long. Plugged in, the cord has a total of 141¼ inches from the wall to the laser. The AC adapter weighs 1.2 pounds. The front left corner contains the Wi-Fi antenna, the USB port for direct computer connection, and the power plug-in receptacle. On the inside left corner is where the laser control cables connect into the frame. Also found are the boot and reset buttons, plus the TF card slot. What the TF card is, I do not know, but it is very tiny. The clearly labeled accessories connectors are found on the left side of the X-axis support bar. In the upper left corner is the switch and plug-in receptacle that allows the laser to engrave on cylinders, like bottles. To use this feature requires purchasing a special cylinder rotary device. Lastly, the power button, the keyed off-on, and the emergency shutdown button are all located on the front right side. All of the buttons and connectors shown in this chapter are explained in Ortur's instruction manual. The Air Assist comes standard with the Laser Master 3 20-watt edition. It is securely packaged in its own box. The Air Assist is nice and basic, having just the power connection port and the air outflow valve. The feet have some spring action to them. This keeps the vibrations that occur when it's running from transferring to the table it is sitting on. The Air Assist is 6 3/4 inches wide, 5 1/2 inches deep, and 3 3/4 inches tall. The air valve is 7/8 of an inch long. The unit weighs 5.2 pounds. The power cord is only 39 inches long. In my opinion, it should be a lot longer. Insert the air hose into the valve. Then push down on the blue ring to lock the air hose into place. The laser module has a similar ring, but it is black in color. A 5-foot USB cable is included. So is a small nylon brush, a black acrylic business card blank, 4 wooden business card blanks, and an acrylic keychain fob. Also included is a pouch that contains the safety goggles. The goggles are large enough to fit over glasses. A plastic parts box contains the interface cable for a rotary engraver, assorted tools for assembly and maintenance, a spare lens, and the tool to replace it. This is the TF card in its protective housing. Even the housing is small. Another nice inclusion are the program-specific manuals for engraving and cutting. There is a manual for Lightburn and a separate one for Gerbil. To use, grab the manual for the appropriate program, look up the material you're working with, then find the column with your laser's wattage. The corresponding box will provide program settings for engraving. The cutting section works the same way. The only difference is that you also have to look up the thickness of the material you are working with. Ortur was very generous and sent me the laser engraving platform. As you can see, it requires assembly. It consists of 5 metal plates that have ridges on one side and are smooth on the other. Plates slide into a channel and screw into place. Assembly was very easy. The engraving platform measures 16 1/4 inches wide. The knobs add another inch. The platform is 15 3/4 inches long. The bed is 1/4 inch thick. It weighs 3.7 pounds. Here's how the back of it looks. I was very pleasantly surprised that Ortur sent me their laser engraving samples kit. As with all of their products, the contents were securely packaged to prevent damage. The kit includes a little brochure telling you what's included, plus a link on where to get use instructions. The contents includes 10 sheets of laser engraving transfer paper with a useful area of 7 1/4 by 9 3/8 inches. Here's an example of it on ceramic tile. There are 10 sheets of colorful metallic scratch art paper that measure 8 by 11 inches. Here's a sample engraving I made using the paper. There is one wooden tabletop picture frame that measures 9 1/16 inch square. The opening is 7 1/2 inches square. They also included a MDF tabletop picture frame. It has the same dimensions as the wooden one. There are 3 pieces of MDF that measure 7 7/8 inches square. They are 3 millimeters thick. Also included are 3 pieces of plywood They have the same measurements as the MDF. There are 6 cork stickers that measure 2.5 inches long by 7/8 inches tall. The 5 metal business cards measure 2 1/8 by 3 3/8 inches. The 5 metal dog bones measure 2 by 1 1/16 inches. And lastly, there are 5 23 1/2 inch long metal chains with lobster claw clasps. On our tour's website, they list the specs for the laser. The font weight is terrible, so let me recap the items I think are noteworthy. The Laser Master 3 is a diode laser. The focal point is 0.08 millimeters square. The laser has a 20-watt maximum capability. It uses spatial compression. I have no idea what that means. The working area is 15 3/4 by 15 inches. The maximum engraving speed is 20,000 millimeters per millimeter, and the estimated life of the diodes is 8,000 to 10,000 hours. Here's a close-up of the label on the side of the laser module. I taped a marker to the laser module so it could draw out the laser's working area. I did this to get a visual of the size compared to the laser frame. Here are the results. The inner square represents the working area, and the outer square represents the laser frame. It measures 15 inches wide and 14.5 inches deep. Now I'm placing a standard pad of 12-inch square scrapbook paper onto the inner square. Lastly, I'm placing a piece of standard size paper, 8.5 by 11, on top of the scrapbook pad. The laser module is sitting flush on the floor. I'm raising the module up as high as it can be. Then I measured the distance from the floor to the module, and that result was 1.5 inches. Now I need to deduct the focus length. The focus length is 1/4 inch. The working depth is 1 1/4 inches. If your material is thicker than that, you will need to raise the laser frame. Ortur sells 2 styles of feet for this. There are knobs on all corners that extend into the laser frame. These knobs stop the X-axis bar, preventing the laser module from making contact with the frame. The X-axis mounting bracket is larger than the laser module, so this further prevents the module from contacting the frame. Ortur's website states that the laser has 7 safety features. Scroll down far enough and there is this hard-to-read section that states the security features as emergency button, safety lock, program operation watchdog, time limit, USB connection monitor, tilt monitor detection, voltage and current safety control system. An easy one to test is the key lock. Without the key, the laser cannot be turned on. With the key in place, it powers up and gives the green go-ahead light. Remove the key and it shuts off. I don't know how to test for all 7 features, but I did move the laser and nothing happened. I lifted or tilted the laser and that caused it to shut off. Pressing the emergency stop button caused it to immediately stop. Let's talk a little more about the emergency stop button. There is an abort button within the program that runs the laser. Click on it and a pop-up confirmation screen appears. If you click yes, this will not stop the laser immediately. The laser will continue to work until the buffer zeroes out. If you need the laser to stop immediately, press the emergency stop button. Let's start with the Air Assist. It has an audible click when it's turned off or on. At the highest, it registered 72 dB, which puts it at the lower threshold of hazardous. The laser ranged from 73 to 76 depending on where I measured. Again in the lower threshold of hazardous, so keep close exposure limited. Begin by disconnecting the power from the laser. Then remove the laser module from the X-axis support bar. Unscrew the protective cap. If needed, clean the cap with a paper towel dipped in rubbing alcohol. I am using 91% because this is what I had on hand. Then use a clean cotton swab dipped in the rubbing alcohol and rub it over the lens surface. Let this dry thoroughly before using the laser. The lens should be cleaned after every 50 hours of laser use. I disconnected the power and inverted the laser module on the X-axis support bar. I used a ruler to identify the center of the laser opening. Then I marked the edges of the module with a white gel pen. Afterwards, I extended the marks up the side of the module. This allows me to visually see where the laser is in relation to the engraving material. It was hard to see where the Air Assist knob was set, so I added a white line to it. Lastly, I had used some wire ties to secure the air hose to the connection cable. During one of my experiments, the air hose got stuck on the YRR switch. To fix that, I added more ties so there was one about every 4 inches. Make sure the engraving platform is far enough to the right to avoid the X-axis module. Here's a back view of the X-axis module making contact with the platform. Next, I placed 2 blocks of wood adjacent to the upper frame. Then I push the platform up to those blocks of wood. This makes the platform parallel to the upper edge of the frame. Lastly, I used the side of a ruler to make sure that the right edge of the platform is parallel with the sides of the frame. This position guide on the platform is awesome. I can remove the board and return it to its original position. This allows me to periodically check results when I'm testing out different settings. One downside is that the laser module can come into contact with the knobs on the platform positioning guide. This can move the platform, causing it to go out of alignment. This is only an issue when working with thinner material. It is never an issue with thicker material that sticks up higher than the knobs. I positioned the laser module so that it was touching the knobs on the platform positioning guide. Then I used the laser sighting to mark the wood. I moved the laser to the right and repeated this process several times. This created a row of tiny dots that represent the upper limit of where the laser can reach while the board is in the platform positioning guide. Basically, you lose 3/8 of an inch. You need to move the laser module using the arrow buttons in the program. You can use the laser spot focus option to set where the laser should start engraving. I found that option difficult to be precise with. Instead, I used the lines that I drew on the module. I begin by using the line on the front of the module to set the left starting point. Then I used the line on the side of the module to finish positioning the laser. To run the laser, you need a program. Ortur has a free app, and the included instruction manual covers the basics of how to use it. But you need a cell phone to run the app. I don't own a cell phone. Todd does, but I didn't want him to have to show me how to use it. Lightburn is a third-party computer-based program that allows you a free 30-day trial. After that, it costs $60 for 1 year, and the cost includes free updates for that year. Once the year is over, the program is yours, but if you want to continue receiving updates, that is $30 a year. LaserGerbil is the other computer-based program that Ortur states is compatible with their engraver. Laser Gerbil is completely free, but donations are accepted. I only used the Laser Gerbil program because I had a limited amount of time to learn how to use the laser and create my video. Ortours app is free but requires a cell phone to use it. Lightburn has a free 30-day trial. After that, it costs $60 to own it. It's $30 a year if you want more updates. Laser Gerbil is free. Begin by setting the laser focus. Carefully move the laser module over the engraving platform. Raise the module up. Position the material under the laser. Lower the laser focusing foot. Then lower the laser module until the focusing foot comes into contact with the board. Lock the laser module in place, lift the focusing foot, and gently return the module to home position. Power on the laser and then open the laser program. I am using Laser Gerbil. In the upper left corner, we see the laser connection port. Click on the lightning bolt icon to the right to connect to the laser. Once the connection is established, the buttons along the bottom are enabled. Use the arrow buttons to move the laser module into position for engraving. Looking at the upper right corner, you can see that the X value is 90 and the Y value is 185. This tells you how far the laser module has moved from home. Home is the lower left corner and has a value of X0, Y0. Click on the Set 0 Point button so that the laser will start engraving where the module has been positioned. Click on the File button to import whatever image you plan to use. Then you get a pop-up screen to set the image parameters. The first few options change the brightness and contrast of the image. I assume the black and white button is for black and white images. The next group of options I haven't played around with yet. The direction control changes the engraving direction, and it's very straightforward. Horizontal is left to right, vertical is up and down, and diagonal is diagonal. The quality is something I will discuss later. The line preview button gives you an idea of how the engraved image may look. Along the bottom are image manipulation buttons. The first one's the reset button. The next four are rotation options. There is an image cropping. Next to it is the auto size to fit. Then there are two buttons I'm not sure about. And lastly, there's a Create a Negative Image button. Once you've set the parameters to your liking, click on the Next button. The next screen allows you to set your laser parameters. The engraving speed controls how quickly the engraving happens. For engraving, you want laser mode M4. The S-Min, I'm not sure what it is, but the recommendation was to leave it blank or at 0. S-Max is the power you want to run the laser at. And the bottom area is for controlling the size of the image. Ortours 20-watt laser can go up to 20,000 millimeters per minute. If you enter a value higher than that, the box turns red. Same thing with some of the other settings. The bottom area of this screen sets the image size. Auto size fills in the width and height based on the source image DPI. So in this example, the width is 142.3. 1 inch equals approximately 25, so 142.3 for the width means 5.7 inches. That's larger than what I want for this test, so I am manually setting the width to 50, and it auto-calculates the height based on the ratio. Once everything is set, click on the Create button. Now the image appears in the main screen. Click on the green Go button in the upper left, and that starts the laser engraving the image onto the board. As the image engraves, the little blue plus sign indicates where the program is at sending the info to the laser. After the job is done, the laser returns to the starting point. Click on the Home button, and it's all done. And here's how the engraving turned out. I'm using this black square to help demonstrate the lines per millimeter. When I put the quality on 1 line per millimeter, I get the following result. The screen shows a single line for every millimeter of the black square's size. The resulting engraving looks like this. You can easily see each individual line that was engraved. As I increase the number of lines on the screen increases, and so does the number of lines on the engraving. The maximum number of lines is 20. As the number of lines increases, the engraving gets darker in color. From 10 on, I don't see much of a change other than the overburn increases. Lines 16 and 17 overlapped because I forgot to reposition the laser. Here is another test panel that I did. From left to right, each column was created with a higher power level, starting out at 10% and increasing to 100%. Each row represents a different number of lines per millimeter. As the power and the number of lines increases, so does the darkness level. With this last test panel, I kept the power and the number of lines constant. Then I increased the engraving speed until I reached the laser's maximum capacity of 20,000 lines per millimeter. As the engraving speed increased, the color decreased. I'm doing a test burn with the Air Assist turned on. From what I have read, the Air Assist directs the smoke away from the laser beam so that the results are cleaner. Also, the Air Assist helps keep the laser module cooler, and this is supposed to increase the performance and life of the laser. With this second test burn, the Air Assist is turned off. James Dean Designs has a very informative video that explains why Air Assist is important to use with the laser. I'll put a link to his video in the description below. Here are my test results. The left square was done with the Air Assist and the right without. The left side is much darker and more uniform in color. My first practical application is pattern transfer. I'm engraving my Vista House pattern onto a piece of basswood. The major settings I used are 8 lines per millimeter, 14,000 as my engraving speed, and 15% power. Here's how it turned out. The lines are dark enough for me to easily see. Plus, the lines are barely engraved into the wood surface, so I won't have a problem blending them into the artwork. My second practical application is reproducing artwork. For this, I am using my chipmunk artwork and laser engraving it onto a piece of basswood. For this reproduction, I am using a 2-pass engraving method. During the first pass, I use low contrast and engrave at a high speed. My lines per millimeter is 8. My engraving speed is 16,000 at 30% power. This creates a base layer of color onto the board. During the second pass, I use high contrast and engrave at a lower speed. This emphasizes the darker colors of the artwork. Here's how the reproduction turned out. This looks pretty good, but it's not close to what the original looks like. I don't know if that's because I'm using bad settings or a limitation of the laser. Now I am engraving the chipmunk onto a piece of birch plywood. Again, I am using a 2-pass engraving method. The principles are the same as the basswood, but I use slightly different settings. Here's how it turned out. For whatever reason, the grain pattern is more noticeable with laser engravings than it is pyrography. Also, if the engraving is held at a wrong angle, it can be difficult to see the engraving, something I've never noticed when doing pyrography artwork. Next, I'm trying out watercolor paper. I'm using Canson Heritage 100% cotton 140-pound paper. I only did one engraving pass on the watercolor paper. Here's how it turned out. It's okay. I'm sure I could get better results if I did more test burns trying out different setting combinations. My last material to try engraving on is leather. For this, I am using leather I bought on clearance. It's really thick and poor quality, so perfect for testing. I'm using the settings of 8 lines per millimeter, 18,000 engraving speed, and 30% power. Here's how it looks. It turned out great. It looks better than anything I've ever been able to burn onto leather. I'm really impressed with the results. Here's another reproduction on plywood I did of my Misty Marina artwork. I haven't got the settings nailed down yet, but I'm rather impressed with the amount of detail the laser captured, especially in such a small space. Each test engraving measures 2 1/4 inches tall by 4 inches wide. My last practical application is creating a test panel. I want the same image in each square on this board. Exact reproductions are a perfect job for the laser. My plan is to use a different type of medium to color each of the butterflies and see how they compare. I was dreading having to trace and burn in the same image 16 times. With the laser, I got the panel done in about 15 minutes. That was a huge time saver. My first fun project is to create a simple greeting card. I began by using my purple iris pattern. I'm drawing additional lines onto the flower to give it more shape and visual interest. The original pattern is available on my website for free. I'll put a link to that in the description below. Next, I secure a piece of watercolor paper to a rigid board. I'm using the same Canson Heritage brand that I used before. Then I engrave the image onto the paper. My settings are 7 lines per minute at 9,000 speed and 100% power. After engraving the paper, I lightly rub over it with a pencil eraser to remove paper dust. Next, I'm mixing up a solution of very diluted purple watercolor. Then I apply the paint to the flower to give it a hint of color. As you can see, I applied yellow to the background. I highly recommend applying the paint with the card lying flat. That way it won't run past the flower edge like mine did. This is another fun and super simple greeting card. Print out the iris pattern onto paper. Again, I'm using the same brand of watercolor paper I've been using. Then draw a decorative frame around the engraving. Afterwards, cut along the frame lines. Yes, the laser could cut this for me, but I didn't have time to get that worked out. Select the card paper, then apply glue to the back of the engraving. Press the engraving firmly glue side down to the card paper. And now you have a beautiful card ready for the giving. For this project, you need a line drawing of your choice. I am using my dragonfly pattern. It's available on my Etsy page. I'm adding additional lines to give it more visual interest, and I'm thickening up most of the line so that the design will stand out better. Next, I secured a piece of scratch art paper to a rigid board. Then I engraved the dragonfly design onto the paper. The results are colorful and nicely detailed. I did discover that you have to be careful with the engraving power. With the colorful dragonfly, I had the laser at 15% power, but my first test I used 30% power. Notice how dull the color is. Basically, I engraved most of the color off the paper. With this project, I'm engraving a mandala design I found on the internet onto a piece of MDF. I will put a link to the design in the description below. If you do this project, make sure the area is extremely well ventilated. I wanted the design to be deeply engraved into the board, so I'm using 10 lines per millimeter using a 6000 engraving speed at 60% power. Once the engraving was done, I lightly sanded over the board to remove some of the overburn, or the discoloration of the board adjacent to the design. Afterwards, I filled the engraved design with metallic acrylic paints by Shuttle Art. I used the color straight from the bottles. I had originally planned on using a number of colors, but decided it was too gaudy looking. So instead I simplified things and only used 3 colors: champagne gold, gold, and orange. It turned out really nice. Plus it looks awesome in the picture frame included with Ortour's engraving samples kit. I am using ceramic tiles bought at a home improvement store. Begin by cleaning the tiles with glass cleaner. I'm using a generic brand of Windex. Then let the tiles dry before proceeding. With one of the tiles, I am using Sharpie permanent markers to color a design onto the tile. Then I apply drops of 91% isopropyl rubbing alcohol over the tile and swirl it around to mix the colors. Afterwards, I use a paper towel to blot off some of the color and create a pattern. This is not a necessary step. After it dried, I applied 2 light coats of clear finish to protect the color. Next, I cut 2 pieces of the laser engraving paper and placed them in water to soak for 5 minutes. The black engraving material will float free of the backer. Remove the black material and place it onto the ceramic tile. Afterwards, carefully squeegee out the air bubbles. Don't place the paper vertical into water. It wrinkles up, making the paper slightly more challenging to work with. Wait for the laser engraving paper to completely dry before proceeding. I let mine dry for several hours. Once the paper is dry, engrave the desired image onto the tiles. I am using the iris design that I used for the greeting cards. I used the following settings on both tiles: 6 lines per millimeter, 4000 engraving speed at 40% power. Here's how they look after being engraved. Now they need to soak in water for 10 to 15 minutes. Then peel up the black laser engraving paper. The large areas around the iris pull up rather easily. As you can see, it also removes the color from my tile, so that experiment was a complete failure. The small pieces of paper on the iris are more stubborn, so I used a Scotch-Brite pad to gently rub over the area. A fingernail also works. Here's how they look. The previously colored tile did not engrave as darkly as the uncolored tile. For the next step, I am carefully applying some alcohol ink over the iris design. I used fuchsia on the flower and lime green on the stem. Then on the other tile, I'm using the permanent Sharpie markers. I let both tiles sit for 5 to 6 hours to give the color a chance to bond with the engraving. 6 hours later, I wetted a paper towel with the rubbing alcohol to remove the excess color from the tiles. To clean up the background around the design, I used a paintbrush dipped in the rubbing alcohol. The tile colored with the alcohol ink is more vibrant than the permanent marker. That might be due to the fact that the engraving was darker. It is something to experiment with at a future date. Here is my original test tile. I did discover that if you don't engrave at a high enough power, the paper does not bond with the tile. Use the engraver in a well-ventilated area. I've got the laser on a table just below a window, and I have a small fan directing the fumes towards the window. Plus, I have a big box fan in the window to suck the fumes out of the room. Even with this setup, I did not feel comfortable enough to engrave on things like plastic or metals. Use uniformly well-lit photos of your artwork. Take them before the finish is applied. I really wanted to reproduce my tiger artwork, but my photo wasn't good. The light is brighter at the top of it. My test engravings reflected that. If I adjusted the brightness on the image enough to show the body, I lost most of the color on the face. If I kept the color on the face, the body was really dark. Use a nice quality thick paper if you engrave on it. I used 140-pound paper, and even with that thickness, some of the engravings either cut cleanly through the paper or came very close to doing so. I recommend engraving small images of your artwork as you test out different laser settings. This will reduce the amount of waste you produce. I also recommend keeping a journal to document the settings you use for each test engraving. Once you determine the best test results, you can easily look up the settings so that you can replicate the results. Lastly, I discovered that kneadable erasers worked great for keeping the engraving material in place. It can also be used to move the board further away from the knobs on the engraving platform guide so that the laser module won't hit them. Plus, the eraser's thickness can be reduced to easily fit under the laser module. I will put a link to the eraser in the video description. I liked how easy it was to put the laser together. In under 90 minutes, I had the laser assembled and had created my first engraving. I like that the laser comes with adjustment tools and a spare lens. Hopefully I won't need either one. I really like the fact that safety goggles are included. The engraving guideline has been extremely helpful. It's wonderful that the connection cables are clearly labeled. I like the fact that the Air Assist has anti-vibration feet. The engraving platform guide makes it very easy to return the board to its exact location. Ortur has some nice accessories like the rotary tool and the expansion kit. Ortur's website has free patterns you can download. Ortur's YouTube channel has a number of helpful videos. Speaking of YouTube, there are a lot of channels that have videos specifically dealing with the LaserMaster 3. The videos cover a wide range of subject matter, so it can be easy to find videos that help expand your laser knowledge. I am super impressed with the level of detail the laser can capture, even on small engravings. I love how well the laser engraved leather. I'm so impressed with the results, I'm not sure I will ever hand burn leather again. I don't like the fact that there isn't some easy-to-use, built-in way of aligning the engraving platform with the laser. I absolutely hate the location of the Air Assist on-off switch. I really wish it was located near the laser on-off button. I don't like the fact that the engraving platform knobs stick up high enough to catch on the laser module when using thin material. I dislike how you lose 3/8 of an inch of working space at the top of thin boards when using the platform alignment guide. The framing option is a great way to make sure that the engraving size will fit on the board, but on softer materials like MDF, it scores the material. The last thing that I dislike about this laser, and it's something that probably all lasers share, is the noise and the smells it generates. As of September 2023, Ortur's LaserMaster 3 20-watt edition costs just under $1,300. There is a $300 off coupon, and that brings the price down to just under $1,000. And it's important to note that the laser comes with the Air Assist. I was told that the diodes will last between 8,000 to 10,000 hours. So let's go with the lowest number of 8,000. So if we divide 8,000 into $999, we come up with a laser cost of 12 cents an hour. According to Energy Sage, the average residential electric rate is 23 cents per kilowatt hour. This means if you have a 100-watt light bulb on for 10 hours straight, it will cost you 23 cents in electricity. 1 hour of use costs a little over 2 cents. The laser uses 120 watts per hour. You get 8.3 hours of use per kilowatt hour. This gives a cost of 2.7 cents per hour. The Air Assist uses 25 watts per hour. You get 40 hours of use per kilowatt hour, and that results in an hourly cost of under 1 penny. If we add all of those together, it costs a little over 15 cents an hour to run the laser. The chipmunk engraving on plywood measures 8 by 10 inches. It took 69 minutes to create, so that cost just under 18 cents for the engraving plus the cost of the board. The chipmunk on basswood measures 6 by 8 inches, and it took 57 minutes to do. So its cost is just under 15 cents plus the cost of the board. The chipmunk on watercolor paper measures 7 by 10 inches, and it took 37 minutes to create. It costs just a bit over 9 cents to engrave, plus you have the cost of the paper. Lastly, my engraving on leather measured 8 by 7 inches, and it took 26 minutes. It cost just under 7 cents to engrave, plus the cost of the leather. Let's start with the pros. The laser is easy to assemble and get running. I had it assembled and produced my first engraving in under 90 minutes. The diodes have a long life, estimated between 8 and 10,000 burn hours. It is possible to purchase a replacement laser module. There are some very nice accessories available. It has great safety features. The laser has a low cost per hour to operate. The laser can engrave on a wide variety of materials. Plus, the laser can cut through a number of different materials and material thicknesses. It can capture and replicate amazing levels of detail. There are a lot of videos explaining how to use the laser available on the internet. Ortur has a number of free downloadable projects. And from a business perspective, the laser is not very expensive. Now let's cover the cons. The material surface must be uniformly flat for good engraving results. Engraved reproductions do not look like pyrography. The laser is large, so having a place adequate to operate it or store it can be an issue. The laser has a huge learning curve. It can take a lot of trial and error to get the desired engraving results. Heavy fumes can be created. You must use the laser in an extremely well-ventilated area. The laser is noisy, at least I think so. For a hobbyist, the laser is expensive. The replacement laser module costs almost as much as the entire laser. In many aspects, that makes sense. I have been impressed with what the laser can do, and I didn't test all of its capabilities. For example, I didn't try engraving on cotton material or cork. Plus, there are a number of mediums like stone, metal, and acrylic that I felt my setup wasn't safe enough to engrave on. I know a lot of the laser owners use them to cut materials, and I didn't do that for two reasons. One, I couldn't think of an application that related to pyrography, and two, lack of time. When I received the laser, I naively thought within a week or two I will know everything I need to know about the laser. Boy, was I wrong. The laser has a very high learning curve, and I'm sure that's applicable to all lasers. It took me several weeks just experimenting around with the different settings before I got a basic understanding of how they impacted an engraving. Let me point out that when I first got the laser, the area I live in was experiencing really high heat. So that limited the time that I could use the laser to a couple hours in the morning before I had to close the window. So that really impacted the time that I could spend learning about the laser. As my husband loves to point out, I'm excessively picky. I watched several videos of people doing reproduction engravings of photographs. They were really proud of their results, and all I kept thinking was, they're just okay. From my viewpoint, if I'm going to make reproductions of my artwork to sell or even give away, I want them to be the best that I can make. And I am willing to spend the time to do test burn after test burn to get the settings just right to get the best results. All of that said, I think Wertür's LaserMaster 3 20-watt edition can make fantastic reproduction that can capture amazing detail. What impressed me the most was how well it engraved on leather. To date, I have been disappointed with all of my attempts on burning on leather. After seeing what the laser can do, I'm planning on using the laser on all of my leather projects. If you are thinking about starting a pyrography business, or maybe you already have one, I really think the laser can be very beneficial. You can incorporate your artwork into creative signs. You can sell reproductions of your artwork. You can do reproductions of your artwork on such a wide variety of mediums like watercolor paper, leather journal covers, drink coasters. The possibilities are endless. Well, that is it for this video. Thank you so much for watching, and I will see you soon.